Hey guys, welcome you all in Technology to the Point. Today we will talk about Docker, what exactly it is, and how it is related to the technical terms and what are the underlying technology on which this Docker is created and how it helps container to create and run application inside that one. So what we will cover in this video, we will talk about containers, container runtime, introduction to Docker, Docker features, DockerFile, Docker image, and then we will go through the Docker architecture. Container is a technology which helps us to run one or more processes inside an independent and isolated environment. If you see here in the screen, you can see blue box, red box, and purple box. These are the containers. What exactly it is having? It is having the application and the required binaries to run that application full-fledged. What these containers do, they uses the same operating system. Means there will be a host, for example, your machine. On that there is some operating system is installed, either it is Linux or Windows. And top of that, we will install container runtime. That is the Docker here. So there are other Docker container runtime available in the market, but Docker is very much popular, and right now most of the organization using it. So this Docker, what will help? It help us to create these containers and manage, or we can say it manage the life cycle of this container. So these containers will run on that particular host and will share the same operating system. And it support all the majors Linux and Windows Server. The benefits of containers, it provides speed as there is no need to boot the operating system. That means application will be up and running quickly in seconds. It is very much portable as very less dependency. So we are able to move them between from one host to another host, or platform independent as well. Uh, if we talk about efficiency, yes, due to less overhead of operating system, that means we can utilize our hardware box very efficiently. Means if we talk about compare our containers with the virtual machines, if one virtual machine to run one application takes around 1 GB of RAM, for an example, the same application can run in a container with 100 to 200 MB. So you can understand it is too much fast, way more faster than the virtual machines. So what is the difference between the virtualization and containerization? See, these also, if we talk about the virtual machine, they also hosted on the operating system, and then it uses the physical hardware server, right? So the here, if we talk about the virtual machine, what will happen? We have a hardware box that might be ESX or your normal HP server. On that, we install some operating system. Then we install the hypervisor, which help us to create the virtual machine. And what these virtual machine do, it is kind of a splitted part from this hardware box, this physical server. So uh, so it is the hardware level abstraction, we can say. So if we have 16 GB of RAM in the physical server, if we want to create virtual machine of 4 GB each, then we will be able to create maximum 4 virtual machines, right? But if we talk about containers, what it do? there is a computer that can be your Windows machine or Linux or some server, right? On that one operating system is installed, and top of that we install the container runtime, either Docker or others which is available in the market. I don't want to talk about them to divert this topic, so let's stick with the Docker. Once we install Docker, that will help us to create containers top of this host. But it is not predefined memory assigned to them. Means if it is really means it when it will run, they will use the same operating system. So there is no separate license required. But in virtual machine, we require operating system license for each and every virtual machine. Then only we will be able to run our application. But in this case, we will go with the single license of the operating system, and we will be able to run our application inside these containers. And these are isolated, so they are not in connect with each other. But there is a way of to configure networking within these containers. So we can, if this container want to talk to the host or talk to internet or want to communicate among each other, there is a way to define that one. But by default, they are isolated and they are not in communication between each other. Now let's talk about Docker, what exactly it is, for which we came to this video. So Docker is an open source platform which help us to manage the life cycle of containers. So if we talk about Kubernetes also, there is Docker install available on each node that help us to create, remove, delete, modify the containers. Kubernetes is just to manage the cluster. So here we will talk about Docker, what it do. It works on build, zip, and run model. What that mean? That if you have any application ready, means your developer, you belong to one organization and your developer developed the application. Now you have all the required binaries files and the application file with you. What you will do, this Docker will help us to create image out of that particular application code, application files we can say. Once the image is ready, then Docker will help you to ship that particular image to a central location. So either you can say it's kind of a repository where you can ship it, or if you don't want to ship it, you can use it on your local system as well. That's all depend on you. Once that is shipped to there, then we are free to pull that machine from the central repository or your system, and we can run that image which is created with your application. So once we have the template or image ready, we can run multiple uh, instance of that particular image, and the running instance of that image is known as a container. So that's why the application which supports containers, or we can say the application which runs inside the containers, are known as containerized application. Docker uses CRE, that is Container Runtime Engine tool, or known as a Docker engine as well. Or we can say Docker Daemon to perform all the tasks of this on the containers. What are the features we have with the Docker? It is easily scalable due to lightweight. We are able to quickly create the container, remove the container, so we can escalate very easily. And it is very fast. As I mentioned, it uses very less space, and it is known as a consistent delivery model for an application. So quickly you can run the image and execute the instances. It reduced the infrastructure and maintenance costs. I will say it reduce the huge cost on the infrastructure side as well as on the maintenance side. It runs more workload on the same hardware in comparison to virtual machines. It ability to reduce size, and it provide you the isolated environment for the application. So on the same host, you can run multiple applications. But in earlier days, you know that we were used to run one application on one physical server, right? But in this case, we can run multiple application on the same host. And if we talk about the numbers, it's like m- way more than the virtual machine on the same host. And we are talking about the same size of physical server. The editions we in the market, we have two editions of the Docker. One is Enterprise Edition, another is Community Edition. As for development and testing purpose, we can use this Community Edition, but we will not get any support from the Docker. There is a community forum where we can raise our concern, and there are many Docker captains or the members who helps each other. But if we will go with the enterprise edition, it is mainly for the production environment, and we will get a direct support from the Docker side. If we talk about the release in enterprise edition, they only release the stable version of that one, so we will get released little late there. But in community version, every 2 to 3 months, we will get a new version of the Docker. You can see this image. It supports many operating system like Windows Server, CentOS, Ubuntu, Red Hat, Azure. Even it supports cloud as well. And now more all the cloud services using Docker for playing with containers. Uh, Now we will talk about the underlying technology on which this Docker is created. So it is the basic of this Docker. So Docker is written in a Go language, that is also open source language. Most of the powerful tools are created on this language. If we talk about Kubernetes, if we talk about Terraform, these all are created written in Go language. Uh, Second thing, we have the namespaces. To provide the isolated environment for the container, it uses the namespace. It's kind of a separate partition is within an host. So our container will run isolated or independent environment. Control groups. Uh, As we know, if we will not put any limit on one container, that can impact other containers as well. So what it do, G groups limit an application to a specific set of resources. So one container can use that particular limit of storage. So the application which is running on one container will not impact on other containers and will not use the resources of other containers. UFS are the file systems that operate by creating layers, making them very lightweight and fast. So that how the layers are created for the container, we will see in coming slides. Just to understand, we need to understand this thing that it helps us to create the layers within the image. If the image having the less layers, that means it is the lightweight image. If it is having more layers, then it is a heavy image. How we can say that how these layers are created within the image, how it is impacting, that we will see in the coming slide. Now let's talk about container format. Docker Engine combines the namespaces, control groups, UFS into a wrapper. That means it combines all the underlying technology and wrapped into one single package that is known as a container. So that is the format of this containers. I hope it is clear now. Let's talk little bit about the Docker engine because it's known as the heart of the Docker. So what exactly it is? It is a container runtime engine that installed on your host machine. When you install Docker, engine is also installed by default in your host machine. It works like a client server model and it is having three main components. That is, one is having the server that you can see inside that one, Docker Daemon. Second, we have the REST API, and third, we have the Docker CLI, command line interface. So, this command line interface is known as a client that requests everything through some command. Then these command will reach to server. How they will reach? REST API will take that commands and send it to the server. So this is the very simple format that whatever command you will give to Docker CLI, REST API take that command and send it to server, and some server will perform on those commands. So what it do? This Docker engine manage the network, containers, images, data volume, everything. So you can understand now. This is the heart of the Docker. So it manages all the actions which is required, or we can say which is required to function for Docker. So these are few components that we need to understand before going to the architecture. How, what exactly are these components? So first we have the Docker file. Uh, Docker file is a simple text file which is having the commands in sequence. So what happens when we have the our uh, application file ready, right? We need to build the image of that one. So this Docker file will help us to create that image with the help of application files. So we execute some commands in sequence. How it's look like, I'll show you here itself. Uh, what is Docker image? When the Docker file is executed, it creates the Docker image after running all the commands in the sequence. Earlier in previous slide, I mentioned about the layering part, right? So the commands, if we have the more commands in the Docker file, our image will be heavy. If we have less commands, that means our Docker image will be the lightweight. Docker container. Uh, Docker container is created once the image is run. So when we execute the image, our container will run, and inside that one we can execute. It will run with the it will run the application for which this Docker image is created. So we have the application ready. With the help of this Docker file, we will create the Docker image for that application. When we run this Docker image, we will have the containers, and our application will be up and running. So this is the Docker file format. If you see, it starts with from that if we required any image to execute or from where it need to execute, then we have the working directory. Then we need to copy command. That means it will copy all the required files which is mentioned in this folder. Then it will run some tool which is required, and then we will expose that on this container to an port, so we will be able to access that application. Then we have the commands, then we will copy all the files in the in that image. Now let's talk about Docker architecture. It is very important to understand how Docker works. So it is having three main component, that is client, Docker host, and the registry. Let's understand. We have the application ready. and we are the user. So we want to create the image of that one. Then which action will be executed? So it is represented with the green dots. For that we need to run Docker build command. Once this command is run, it will be sent to the Docker daemon. That is our server. So what it will do? It will create the image and we will have the image here. Now, if we want to keep there is two things. Either we can keep this image with our in our system itself, or we can push that image to the repository. Repository is something it is given by the Docker. It's kind of a share location where it is having two kinds of repository. One is private and public. Uh, with the free edition, you can have one private repository and you can use public library registry as well. So repository is also known as a registry. So you can keep your image there. Either if you want to make it public or private, it is your choice. If you make it public or private only, then you are the only one who can use this image. But if you if you make this public, then others can also use this image. Let's talk about next command, that is the Docker pull. What it do? Once we run this command, then Docker server will go to registry, that is the centralized location, will take that particular image and will pull it and keep it in your system. It will not execute at this time because we are just pulling it. It's kind of a downloading that particular image. Third command, we have the Docker run. So how this for the timing, just think that our system don't have any image there. So how the action will take care? Once we run the Docker run, it will go to the server. Then server will check internally in the local system if that particular image is available or not. If it is available, then it will run from here itself. You can see the purple arrow, and the containers will be created out of that particular image. Suppose if that image is not available on your system, then what will happen? If it is not there, it will show the error that it did not find locally. Then it will search for the registry. Suppose you pull the image with the name of Ubuntu, Nginx, or whatever it is, you provided the image name. So it will search in the centralized location, that registry. If it finds there, it will download it. But there is something you tagging in the sense it's kind of a version of that particular image. As you know that every time something change, or if there is any additional change, we always change the version of that particular image, right? So here that is known as a tagging. So if we don't provide anything, then the last update which is stored there will be known as a latest one. So it will pull that particular latest image from there with the same name. If you have the specific, if you want to download or pull or run any specific image with that, then you need to provide the name with the tag number with the colon. So this is the way how Docker works. These are the few commands, or I can say the important commands to just start our Docker things, or just to play a little bit about the content with the containers with the help of Docker. So Docker version, what it do? It will show the version of Docker client and Docker server. That means it will show that if your server is running. Docker client always will have the same architecture. What is your machine is having, like Windows or Linux. But the server will can have Linux or Windows, because when you install your Docker on your local machine, it will comes with both the architecture Linux or Windows. You can switch it. It's all depend on your application, which application type you want to execute. Docker image. When Docker images, when you run this command, it lists down all the Docker images available on your system. Docker will with the Docker image, it will build an image from a Docker file. We no need to provide the Docker file name. Just the Docker file should be available in the current working directory, means the current folder where we are running this. Then we have the Docker save command that saves the Docker images to the zip folder or .tar file specified with the path, means it will be by default it will take the current working directory. Docker run will be used to run the images. Docker start will help you to start the containers which are in stopped state. The same way Docker stop will use to stop the container. Docker RMI image. It will help you to remove the Docker images from your system. Docker RM will remove the running container. Oh, sorry, remove the containers. And one more thing, we can't remove the containers until and unless it is in stopped state. So that means if the container is running, we can't remove that container from that particular state. First, we need to stop it, then only we will be able to remove it. Then we have the Docker pull. It will pull an image or we can say a repository from a registry. So guys, that's it we have for theory part. Now let's come to the demo parts where we will play with Docker and in this demo I'm using the online portal that is playwithdocker.com and that is provided by Docker and we can use it for our learning purpose. So we will see that how we can run our commands in command line interface and how it will be executed in the backend and how our containers are running, how our application is running inside the container, how it's look like, and we will play with the containers. So let's see here. So guys, this is the environment we have for the Docker. So once we install the Docker from on our host machine, then we will get it. Otherwise, we have the online portal we can say on which we can play with the Docker. So that will help us to learn Dockers quickly and we can play around it. But we had the limited time of session, like 4 hours of session at a time we can get it. Once the session is expired, then your system means your this environment will go and then you can initiate another environment. That's not a problem. So what we discussed in our session now, or we can say in our during the slides. Now we will see the hands-on how the Docker works and right now I did not do anything, just install the Docker on my machine. It is the blank machine. If just want to check if any Docker container is running or not, if you see there is no containers is running and the command for that is the Docker space ps. Let's see if we have any Docker image here. Sorry, the correct command is Docker images. So let's see if we have any Docker image. There is no image at all. So right now we don't have any image, right? So what we let's start. Uh, First we will use the Docker pull command, right? So Docker pull, or what would say, let's directly run one image. So you will be able to see what kind of error we will have. So what I'm doing here, I'm going to run one image that is based on a web server, who, which is based on Linux. Before running this one, okay, let's run it. Then we will check the version and all and the architecture type. So what it will do, it will run this particular image engine. That's a Linux-based web server. Uh, and it will be exposed to the port 8000. So whatever application is running inside this particular image, we will be able to access that application on this port number. How we will access it? If you are using this command on your host machine, then you need to go to browser. Then you just need to put localhost colon or port number. If you are using the online web portal like me, then I'll show you where we need to check it. So, and it will run in a detached mode and it will publish this port number and expose this port number 8000 to the internet. So, if you see how it is running, first it try to the local system unable to find it, the image ng.latest. Then it started pulling it. If it is not found locally, it started pulling from the centralized location. Now, if we will see, you can see this image. And we not only pulled this one, we also created, run this image, right? So we should have the containers running. So it is the container, and we have the container ID, the image name on which this container is running, and then it is showing the status, it is showing the port on which it is exposed. And if you see here, we did not provided any name, but it gave us, right? It's if we will provide the name while running this container, right, with this image, then we will have that particular name for this container. If we will not provide, it will provide some crazy name. So there is one command which I forgot to show you, that was the first command we checked it. Once we get such kind of output, if here you can see it is showing the Docker client and Docker server. The architecture I like it is based on Linux box, and the server is also the same. If you show which language it is written, it's on Go language, and this is the version of that language. Here it is showing the API version, REST API version, and here we have the version of Docker. It is built on this particular date, we can say. So we have many information on this. So now we have what we did. We checked the containers are running with the image, but how we will it is just showing that it is running, right? We don't know what is running inside that particular image. So what we will do, if you see here, this port is coming now, right? So I'm going to run one more uh, container. This time I'm going to expose it on port number 8001, we can say, and I'm going to give the name also. The name I'm going to like T3P, technology to the point. So this time, what is the difference when I run this command and the earlier one? Here the container will run with my name, this particular name. If I'll see now, you can see two containers are running, though both are having different ID. But if you see the name here, the name we gave, we can see that one. And also you can see the container which is having my name is running on port 8001, and the container on which we did not give the name, it is 8,000. So anyone we can check it. For you, I just put it down. So it is showing the welcome to Nginx. Let's go back to this particular portal. So here we see the how we can run the image, how we can run the containers and all. Uh, l- Now just want to remove those containers. So let's try container. I just want to stop this container. As I mentioned you, it should not work. Ideally, so if I see now, sorry, I just stopped it. Okay, so I did not remove it. Now I'm going to remove that one. This one, this is the running container, right? So I'm going to remove this one. When I removing the running container, it is saying that you can't remove a running container. You first need to stop the container before attempting for the remove. If I do the same thing with other container, which is stopped, I'm able to do it. If I'll check all the containers, so it is showing only the when I run this particular command to check all the container, it is showing only one container and that is still running. So let's remove this one and delete it. So now you can see how it is. There is no containers running right now. Now let's remove the images as well. So we will get to know. First, we need to see what are the images ID. So what we have only one image. So what I'm going to do is I'm going to remove this particular image. So it is untagged and it is deleted. So you can see here. Now we have deleted all the images. Let's check them. See, there is no image is available now. I hope you learned something today and if it is new for you, then nothing to worry. We just need it is just a starting to play with containers with the help of Docker. There is more topics to cover, then it will be more clear to you. Thank you for watching this video. If you like the video, then click on like button. That will encourage me to prepare more video like this on different topics. Now see you in next videos. Thank you for watching once again.